Before we look at question 11, right, let's look at a more common scenario that we often see. The more common scenario, right, is suppose you have a light bulb, okay, and you connect it to a wire coil, and then, right, you have a magnet entering, okay. It may be like this, and this guy, right, enters into the coil. And when we expect a light bulb to light up at the beginning when it's entering, we expect it to light up again when it's exiting, okay. And in between, right, when it's like the magnet's deep inside the coil and it's moving, right, you don't expect any change because there's no change in flux linkage. Yeah, the coil assuming is long enough. But this scenario, right, is very different from what we have in the question. Question, right, actually have a number one, right, there's already a power source. So even if there's nothing happening, right, you will have a default current here. Number two, we are not trying to push a magnet through this coil. We are trying to push a iron rod through this coil. So you see, that's a second difference. So what's happening, right, is that we must first consider a solenoid with iron core versus a solenoid without iron core, which is stronger. We know from EM, right, the solenoid with an iron core is stronger because the iron core, right, is a ferromagnetic material. It can enhance the magnetic field, okay, due to its ability to be magnetized. What is the reason behind this? I don't want to elaborate too much, but just know that the solenoid will become stronger if you put an iron rod inside, okay, if it has an iron core. So what is happening, right, is that at the beginning, this solenoid, right, this solenoid originally have a magnetic field strength. Let's say, let me draw 3 arrows here to represent, okay. I don't care what's the direction, it's not important. But when the rod is coming in, right, okay, what happens? As the rod is entering, it is making the magnetic field lines, right, okay, making the magnetic field stronger. So it's creating extra lines, okay, when the iron rod is like here. It makes the B field stronger, so it adds more line. And that causes, right, the flux linkage of this coil to increase because the coil, right, it produces magnetic field, but it also captures these magnetic fields, okay. These magnetic fields also goes through this coil, so there's actually a flux linkage. So as the iron rod enters the coil, the flux linkage increase as a result, and therefore, right, the induced current that flows must try to oppose this change. So how to oppose? You simply, right, drop the current so that the magnetic field, right, become weaker, okay. It doesn't necessarily become weaker than before. It's just trying to oppose the increase in the field strength as a result of iron rod entering. So induced current will try to flow opposite to the direction of the default current, and therefore, right, you experience a dip, okay, when it's entering. So it is trying to say, right, I don't want to become a stronger magnet because that will increase my flux linkage. Yeah. And vice versa, right, when the iron rod is exiting, the solenoid is already used to becoming a stronger magnet, and as it exits, right, it's going to become a weaker magnet, and that will cause the flux linkage of the coil, right, to drop. So the induced current will increase, okay, will flow in the same direction as the default current, so as to oppose the drop in the flux linkage. Yeah. So it will be a bump towards the end. So answer is A.